Just stay close because I don't know where we are.
Oh, hello. So my name is Izaak. I'm here in the CMS control room together with Sonia.
Yes, I'm Sonia. I'm also here with Izaak, of course, and we are happy to show you today something about this one of the 4 experiments at CERN, that is CMS.
Yeah, so I heard that you are sophomores, physics students. So and that Matt already introduced a bit the Large Hadron Collider. So maybe you have seen this nice aerial view before, which is showing Geneva. So you see here, this is a very nice picture from high up. So you see the lake, and Geneva's here at the end, where the river, the Rhone River starts, and then in the back you can see the Alps, like the Mont Blanc with the snowy tops. And then the forests you see on the bottom are the Jura. But in between this Rhone Valley, you have the Large Hadron Collider, which is about 100 meters under the ground. So it's this big yellow circle where CERN...
Izaak, if you don't mind,
Yes.
I interrupt you because as I need to prepare myself to go underground,
yes.
now I leave you to talk about this marvelous accelerator, and I prepare myself. You will see me on the back just preparing to go down, and I will meet you as I'm in front of the entry of the experimental area. Okay, see you later.
Okay, so while Sonia prepares to go downstairs, I will just explain a little bit the Large Hadron Collider. So we are now situated here at CMS. So it's on the opposite side of the main site of CERN. So the main CERN site is here, just at the border between French and Switzerland. And so this is one of the 4 main detectors. So CMS. The other one, which has a similar design, is Atlas. But of course, in my opinion, CMS is the most beautiful, but also the best of the 4 detectors. So Alice and LHCb have a little bit different. Yeah, Sonia says me too. So Alice and LHCb have different designs. But CMS and Atlas are very general purpose detectors that are meant to search for many different types of new physics, but also make measurements and tests of the standard model, like the Higgs boson and things like the top quark. So unfortunately, we're currently not able to enter the experimental cavern where CMS is situated. But Sonia will just go downstairs about 100 meters under the ground and just show you how things look like, and she will show you how we take data there. So this is just a picture of the Large Hadron Collider on the ground, where you can see each of the 4 different detectors, which crosses the border between France and Switzerland. So here you can see Sonia walking in direction of the elevator. So she just left the control room.
Can you hear me?
Yes, we can hear you, Sonia.
Yes, okay, yeah. You follow me. It's very interesting. I heard that you were describing where I'm going. In fact, okay, just reaching the elevator. So we have corridors, as you see, almost there. Do you still hear me,
Yes.
Izaak?
Yes, we hear and see you.
Okay. Yeah. Now, this is one of the entry, but I would like to profit. Here we have close by, we have let's say a real physics, but it's just a representation of the LHC. And as we have experts today, I would like to show them. And please don't envy me too much, because in my hands, I have a beam pipe of LHC, you see? So I hope that I can pass you, let's say, this feeling. This was not used, so I can touch it, but it's real. So my finger, my thumb is a normal thumb. This is as you see, the diameter of the LHC beam pipe. And then, okay, this hole is made to show you how is is done inside, you see. Okay, there is a certain covering, a special covering here. And maybe Noemi, that is, she's with me, can show. This is the inner part, sorry, of a dipole. So one of the magnets, we have 1,232 magnets like that. You see that this is a dipole because these are the cables and they are arranged in 2 poles. So this is where the current, they go through the beam pipes. There are 2 beam pipes. They go through the beam pipes and you have 2 groups, and these make us able to provide a magnetic field that generates the Lorentz force that is bending one side on the others, the protons packets that are flowing inside these 2 beam pipes. Of course, we have along the 27 kilometers, as Izaak was saying, we have 2 beam pipes. But as we enter the experiment, that we will not see the experiment where we will go very close to CMS, the beam pipe becomes only 1. So you have to deviate the beam from one side to a central pipe that goes inside the detector. But I think that Izaak can continue on this in just few moments because he has nice pictures and slides that I don't have here. So I just take another few moments to show you how I enter the experimental zone, and then I leave the floor to Izaak again. So as I told you, we enter through this door that is called a pod, is a door for persons. And what I have to do, I do basically, let's say, 4 checks. First of all, I make myself recognizing using my personal dosimeter that I badge here. Then I enter the door and I step inside, and there is on the floor, as you see this square here. There are sensors, a weight sensor. Let's say I don't see my weight, but the system realizes I'm a person because I repeat, this is a door for people, not for material. I will show you the door for the material. Then as I step in, I cannot bring anything with me, for example, a backpack. So it means that I have to pass a check for, this is made with infrared beams that are checking. I don't have anything with me. I have Noemi in front of me. She's able to bring the camera inside. She's magic. She's a wizard for this because I did many times. I was always failing. The third check that is again personal is the iris check that is done using this machine that you see here, and recognize again me. And of course, you could pass this door for the first 2 checks, the weight and the infrared, but not for the iris check. Now I show you how it works. I hope that it works. Let's see.
Yeah, and Sonia, just for the record, just for the audience, please note the color. And I'm not spoiling anything in the future, okay?
Okay, everything is, it seems is okay. And I'm in, and now I wait for Noemi entering with the camera inside. She's really very good in this. There is a trick. I know there is a trick. She told me. And she has passed. She's doing the iris check now. And that's done. Okay. We proceed through this door. And now we are almost in front of the elevator. Just to show you, there is another entrance here. Here we have other 2 doors for people again, as you see, other 2. And then the door for the material, that is this blue door here. And Noemi, she's showing you how it works. In fact, there are 2 doors, one in front of the other. you put the material inside, you open outside on the other side, external, you put the material and you close the second door. So the material stays inside, in between the two doors for a while. The time you budge through the personal door, and then you open from this side, that is through this key that you see here. And just in front of this, we have the elevator. I just disappeared for a moment to call the elevator. And now you see that it's coming up. As I will be in, is a big elevator. Almost 30 people can fit inside. So I think it's the smallest place that we have here, but is very big in the daily life. We step in, and Izaak, I tell you already, you will lose me. I can be lost in many ways, Zoltan knows, but this is for the broadcasting. So I step in, and now we have the levels. 0 is the surface. -1 is about -80 meters. -2, -90 meters. -3, -100 meters. We go to the -2 now. And I leave the floor to Izaak because the broadcasting will be interrupted.
Okay, thank you, Noemi. Sonia, that was quite smoothly the way you entered in the green path. Because for me, it takes typically several tries before I can enter with the retina scan. So for the elevator, one interesting fact about this is that it's actually, in case there's a fire on the ground, it's actually the safest way to go up. So normally you're not advised to take the elevator when a building's on fire, but in this case, actually the shaft is under pressure, so it's designed to be safe in case if there's smoke or fire on the ground. So you're not supposed to take the staircase because you have to walk up like 100 meters, and many things can happen on the way. So that's why they typically not advise it. So Sonia showed you parts of the Large Hadron Collider, and this is the CMS detector where she mentioned that the beams will intersect. So here you will have just one pipe that guides the protons to the center of the detector where the two opposing beams intersect. And then we can, using magnets, we can make them collide. And then we basically take a picture of collision events. Often we describe the CMS detector as a video camera, or as a camera which takes a picture of proton collision. So by the way, let me know if you have any questions. You feel free to interrupt me anytime. You should have a microphone, so yeah. Just let me know.
You can hear you if you talk. So if you have questions, just interrupt.
Yeah. So feel free to make it a bit more engaging, or if something is not clear, or if I have to speed up, just let me know. So Sonia is here downstairs.
Yeah. Can you hear me also, Izaak?
Yes, we can hear you.
Yeah. No, I wanted to add, yes, two things that, okay, if they want me to show better one part, okay, they can always interrupt me. I can stay a little bit more on one side or one corner. And as you came back in the broadcasting, I heard that you were talking about the stairs. So this usually I do not know, but I do not show, but I can show you the stairs that are forbidden. If I can open, yes. These are the stairs. These are strictly forbidden to be used when there is an evacuation alarm, even if we have here. And as Izaak was explaining, this is because they are not protected as the elevator or the zone that I will show you in a while. Yeah, it's pressurized, yes. But Noemi, she's showing you all the stairs. They are normal stairs, let's say.
So
yes.
Sonia, which floor are you on now?
I'm in -2. That is -80 more or less. To be sorry, -90, -87.9. And this zone that you see here is just in front of the elevator is a safety zone because it's overpressurized, and so is anything can enter. For example, smoke, if it's produced outside these fire doors, that is the real experimental zone. and also, for example, if we have gas leakage, and then we have the big brother, as I call it. So we have cameras from the control rooms. I will show you as coming up the image that they get from here, and we can call the fire brigade. Oh, they know very well if something has happened, better than us. But however, if we want to talk with the fireman, we can always just pull up this device and we can talk with him. All people, let's say they are trained to use a extinguisher, we can start an evacuation alarm. I think here we are really, I would say, much more yes, okay, of course. We have also trained to be first aiders. Yes. So everything is on place. And I think that if you want to come here, you will be really safe. So I go in the experimental zone, the fire zone, to show you two things. First of all, I would like to show you the -100. With the help of Noemi, maybe we can show you the floor there that you see with some yellow, let's say, strips. And there is a wall that now is completely covered by one block of concrete. It seems that there are many blocks, it's just only one, that we push inside to fill this corridor, if you want, that is more or less 7 meters thick. And when there is what we call the short shutdown or the long shutdown, are these periods of maintenance of the detector, and LHC also is doing maintenance. This corridor is open, and so we can go through and reach from here the experimental cavern. But now, as you see, it's closed because we are preparing for runs. You can also see on the opposite side, I ask again the help of Noemi, the surface. If you look up, you will see a small light square or rectangle, I don't know. Yes, closer to the yellow bar. This is the surface where I was before, so really I'm not cheating. I'm really more or less than -100 meters. And maybe you can see also lights. This is, let's say, an artistic representation of how data are taken underground and they goes up to be analyzed. Let me stress one point. LHC is one of the first experiment that tried to connect different topics, different fields that seems not to be very connected. For example, art, photography, music, theater, with science, because we think that in any way you need the creativity to do all this kind of stuff, and also to do physics. You need a lot of creativity. Now, Izaak, I need your help because I entered the counting room, but as you know, you will not listen the noise inside, but I will. So it's really hard for me to talk from this in this room. Mm-hmm. I will try to interrupt you a little bit, but just for a while. So I leave you the floor to describe what we have in this room. And okay, we will meet again close to the red door.
Okay, thanks a lot, Sonia. So I thought it might be useful if we can show just the blueprint of the underground. So where Sonia is now is in the service cavern here, where we have all these servers standing that are taking data from the detector. So normally we don't allow visitors here, but since this is a virtual path, it's easy to access. So here you can see all the cables that are coming from the detector, and here we call this the counting room because these servers are being used to make decisions of which proton collisions we want to keep for further analysis. So we have to make very fast decisions because there are about 40 million collisions per second, so every 25 nanoseconds. but most of these are not as interesting for further physics analysis. And also it's too much data to store at once. So we have to quickly filter out the data, and this is why we have a so-called trigger system that triggers on the data in case we see something interesting like a high energetic particle or some signature that looks like an interesting or exotic physics event or like a new particle. These, yes?
Can you hear me? Just few things. I don't know if our audience was just looking how these cables are arranged. I think it's a kind of art to arrange cables. Maybe because I did in my career, and also to do some cabling, in particular of optical fibers. See the regularity. Sometimes, okay, they are not so regular, but when I'm here and I look how these cables are arranged, I have to say it's really a form of art. And then another thing that I would like to show, as you said, that how many cables we have, these walls that you see here, you see, are kilometers and kilometers of cables. And of course, we have electricity. We could have an issue of fire, and you will see maybe at a certain point, Noemi will show us how many extinguishers we have in this zone, because of course we have, how to say, a step-by-step system to fight the fire in case we should have, that is locally. We have extinguisher, and then we have main systems to try to fight the fire. For the time being, I know that nothing happens. I don't know if Zoltan has other news or Izaak has other news, but to my knowledge, nothing happened, because the safety is one of the most important things in all the experimental area. Last thing I would like to show you, and I will continue inside this room, is that we are just entering zone where these zones are not allowed for visitors. So being in a virtual visit, you get something special. That is that you can follow me where you couldn't go if you would be here in person. So consider yourself lucky. I give you back the floor, Izaak.
Cables look like your labs, right?
So thanks, Sonia. So was there? Did you also want to take the opportunity to ask something, Mats, or?
I was just remarking that the cabling looks like the labs that my class have been working on.
Are they also as neatly arranged, or?
Oh yes, yes.
Okay, great. So yeah, so as I mentioned before, we're now in this surface cavern here, where all these racks are standing. And this is separated by a thick layer of rock and concrete from the actual detector. So what you can see in this blueprint, I cannot zoom in, but you can see, or I can, okay. So this is this cylinder, or this rectangle here is where actually the detector is, and this big circle is the shaft where we drop down parts of the detector when we construct it. And there's here the beam pipe, which comes from the Large Hadron Collider and goes to the center of the CMS detector. And since we have many protons colliding at very, very high energies, this causes some temporary, we call it activation, but it's a type of radiation. And so during data taking, for sure, it's not safe for people to be in the surface cavern. And also sensitive electronics like the racks we just saw have to be really separate from the actual cavern. So Sonia is pointing to something here.
Moment. Yes, I'm in. Okay, I heard that you were talking about this wall. Okay, if you see here, the wall that is there is where, if you want, you start more or less this thick wall that you were talking about. And I have my preferred, I heard also that there was a comment on the cabling, because if you do once in your life, you won't forget that you were cabling. This is my preferred wall.
Sonia, please be aware the high voltage is on.
I know. It's my preferred, not because I can do grilled chicken, but just because you see, it's the way this wall is arranged. It's not because it's red, but look really the regularity. Think how many hours has been spent to cable to make the cabling of these walls. These are normal cables, and in fact, Zoltan was giving me a warning because there are 12,000 volts flowing in this cable. So let's say that is more than a grilled chicken. I will show you. I go now down, and I will show you another thing very interesting. Again, consider yourself lucky. You couldn't be here, but come with me. Oh, I see a chair. Somebody is taking some rest here. But you see, this is below the county room we have seen before. So it means that below the floor in the county room you have seen just a few moments ago, we have other cables. They are arranged again. Okay, look this. Now, I don't want to touch because, but look, this is always
that
my finger.
That you can, no problem.
You know, I prefer to be safe. I don't want to touch. However, you see my finger. You can see they are much thicker cables, and you see again they are very well arranged. In my experience, maybe we would talk later if we will have time. We had also to fold some cables, not only to let's say to route the cable as they are. And now Noemi, she's showing you also some pipes for, I suppose, gas and all the other stuff that we need for the detector. But we are still inside the service cavern. And Noemi, she was just telling me that all these cables that you see here, they go down and then they reach the experimental cavern on the other side. Yeah, so I go back, I think, close to, you know, I'm not very tall. So you see, it's not a big area here, and we have to pay attention also to this part, okay? Yeah, so we go out and we reach, yeah, okay. There is something there, and we reach also the red door here. That then Izaak, he will show you where I am. I just want to mention a little bit. You see here. This is a wall that reminds you a tunnel. In fact, if you go through this door, you can reach the LHC tunnel. Now,
please note the color.
Pardon?
Please note the color.
Okay, yeah. Now, why we have this door here? Frankly, if you need people who are working on the LHC, they do not enter the LHC from this door. And also people working in CMS, they do not care to go here. So if you see, is a second safety path. Just because a few meters after this door, there is another elevator, and so is the second escape path. You see that we need a good reason to open this door because it's sealed. So if we do, we are allowed, but we need to have a good reason. Otherwise, we can get some, let's say, issue problems. However, why I want to talk about this door? This is because it is the reason why I can be here now. Otherwise, all the other experiments, I mean Atlas, Alice, and LHCb, they are closed. You cannot go underground. And the reason is because there is a rule at CERN that has been was agreed that in case, in particular for visitors, if you have a group of visitors here and something happens, so there is an evacuation alarm and you have to evacuate, you can use, as I was using now, the classical path, but maybe you are in need to use the second escape path. And all the other experiments, they have the second escape path through, let's say, basically you need to go through the experimental cavern to reach the second escape path. I know that there is the map, so it's then I leave Izaak to show better this path. But however, it means that when you have an evacuation alarm, of course, you don't have the beam, and so could be, let's say, safe to go through the experimental cavern, but however, there is a certain radiation background. And it's not nice, let's say, that after a while somebody comes because maybe has an issue, an health issue, and says that this was because I was going through the experimental cavern. So let's say it's much safer to say that if we need to go through the experimental cavern, we prefer visitors not to go. And so if there is no option, we just close. CMS, frankly, I don't know because I was not here at that time, but if it was done on purpose or just by chance, the second escape path is just on the side of the service cavern, which means that you can come here anytime along the year. What you cannot do is to enter the experimental cavern that now I will show you the entry, but in any case, you see is in this corridor I move. So it's just there. We will stop in few meters from here. But however, you cannot you cannot go through let's say through this door that you see here because now it's closed. But however, you can come underground. And this is not possible for the other experiments. Izaak, I leave you the floor just for a moment, and I prepare my show here with the magnetic field, I hope.
Yeah, and also please note the color.
And the big flashing danger sign.
Yeah.
So yeah, so like we said before, because of radiation, we won't allow people inside the service cavern. So maybe I can just quickly show the CMS detector that we fortunately cannot see in person today. But so this is just a cutaway. So as I mentioned before, it's like a camera. It has many different layers that are meant to do different things, measure momentum and energy. And inside the detector, you have this really strong magnet, which is shown here in white. And this is meant to bend the path of particles that are emanating from the collision point. So if we didn't have a magnet, all the charged particles would just be straight lines. But thanks to this really strong magnet, here this is also a nice picture. So this is the cross-sectional view of just one sector of the cylinder part, which we often call the barrel. And so here the magnet, which is a superconducting solenoid, so it's like a big cylinder, which is cooled so that it can have a magnetic field of about 4 Tesla within the volume. And so here you can see an example in blue of a muon, which is coming from the collision point, bending downwards, and then as it goes outside the magnet, it will bend the other direction. And so here you also see the different layers of the detector. So in the heart we have a silicon tracker, which is kind of like a pixel camera, which measures the position of charged particles that leave a small ionizing track or a signal in these silicon electronics. Neutral particles will just they won't be bent by the magnetic field, so they will just form a straight line still. And then after we measure the path and the curvature of these charged particles, they will reach the calorimeter. So here calorimeter means like measuring the energy. And we have 2 different types that are made from different materials, and they're optimized for measuring the energy of different types of particles. So the eCal, or the electromagnetic calorimeter, is meant for things like electrons and photons that will start to create things like so photons will convert into electron positron pairs, and some electron positrons will create like bremsstrahlung, and so together they form these. They will shower. We call them showers. They will create a lot of secondary particles in this dense material, and then we can just convert this into light and measure it as the energy as an electronic signal. And then after the electromagnetic calorimeter, there's the hadron calorimeter, or HCal, which is meant for, as the name suggests, hadrons. So things like protons, neutrons, pions, kaons. And so they will also shower. So these materials are more optimized for undergoing nuclear interactions with these hadrons. And so here also we can let them shower and then let them completely absorb all their energy, so we can measure their energy. The only particles that escape the detector tend to be neutrinos, because they're really light and and they're neutral, so they will just go through the detector. The other particle that can reach all the way outside is the muon, which is again this blue line here. And to identify the muons and separate them from other types of particles, we also have muon stations outside. So these are muon detectors, and so here you see some of these blue hits here where we measure the position of a track, and this allows us to match it with the tracker on the inside and say, this looks like a muon. So I don't know if Sonia had something prepared for you. I don't know if we're ready for that.
Interject just for a moment. So some of you went to see Professor Heinz's lab, where they're making silicon sensors. So the sensors that they're building here at Brown will be brought to CERN and installed in that part of the detector in a couple of years.
So that will be here at the center. So this is the zoom in. So here you can see. So did you say the strips or the pixel?
The outer tracker upgrade.
Okay, the outer tracker here. So yeah, that's the blue part here. So you see the many layers of these strip detectors. Yeah.
Cool.
Izaak, can you hear me?
Yes, Sonia, we can hear you.
Okay, yeah, no, I leave the floor if there are questions, and then tell me when I can show you the magnetic field.
Are there any questions? Or maybe you can go ahead. Some students will probably need to start leaving at about 10 to the hour. So maybe we can do the magnetic field show. That sounds cool.
Yeah, okay, so now I wanted to show you, I know you are experts, and I was listening the serious, I'm trying to be a little bit funny because, okay, you know, it's many years I'm physics, so I can allow myself to be a little bit, let's say, do this, and I leave serious things to other people. But however, let's say, I think that the beauty of physics is also that you can really see physical phenomena with simple things. And what about to use a chain of clips to check that you have the magnetic field? This is not, okay, I can go back if you want. You see, I destroyed my chain, but however, I can go back and you can see that this chain is not magnetized. You see here, you see, I put against the wall, is completely not magnetized. You see, okay, I destroy it, but however, because I have one clip that doesn't work too much, then I have a more performant on the other side. Let me just try to do some experimental physics. But you see, okay, experimental physics. I just repaired the funny clip. Experimental physics. You see, this is completely unmagnetized. And now you follow me against the floor, and I hope that you can see this clip just reacting and detecting the magnetic field. You see, it starts to bend. It's not so evident because this has plastic something, okay, but however, it's, you see here, it's not me. Or maybe I'm magnetized with a clip, I don't know. Oops. Myself. Just look here, okay, and then you see. And okay, we can, I don't know if with this one, I can do something. I prefer to use another one. So I leave the clip on the floor and I take another one that is much more performant. I hope that you can see this. This is totally metallic. And with this, we can do this. You see, we can adjust the detect. I remind you that I'm in a corner, maybe you can see later with the map, that is more or less, let's say, 30 meters from the center of the detector where we have a 3.8 Tesla. So Just one, let's say, thing for my ego. That is, okay, my name is Sonia, so you see a nice S here. Just, oh, but you know, all physicists, they are very egocentric, I would say. And now let's show something else. Yes, you need a strong personality, otherwise you couldn't talk and present your results in front of a big audience where there are many really clever people, I would say. You need really to be very performant. And now you can see a nice pendulum here. It is just oscillating because you see this wall is not magnetic, but the screws, they are. So you see here, and then another thing that happens just because, okay, I was playing with my hands and I did some different kind of mess here. This is what I call the magnetic swing. That is this stuff that you see, where you have a balancing of the gravitational force, the magnetic force, and you just, just believe me, I'm pushing the chain down and I feel on my hands the elastic force pushing my hands up. It's not just that I can feel under my finger that is coming up alone. It's really nice. I could spend hours doing this. This is a very relaxing activity, I can tell you. This is really relaxing. But then,
I have to confess that this is the point usually where we used to lose the guy.
Yes, it's the other way Zoltan lose me. I know. But just to tell you, okay, this is a very naive object. And I know that I renew my request to the safety staff, but I know that they will never allow me to do this. During, you know, there are periods the magnetic field is not on, so the magnet is switched off. And I was asking to be in this point when the magnet is, they are ramping the magnet. Why? Because I would like to add clips for each step. They are increasing the magnetic field in such a way that I could measure roughly, of course, the magnetic field when I'm here, just counting how many clips I have in my chain. But I know they will never allow me because let's say that there could be an issue when you ramp the magnetic field. So it's better nobody's around. This is why
Sonia, maybe at that point where you are, we can arrange. So during the next technical stop, I think we will do. Yeah.
Hey guys, our ears I'm asking from this. Zoltan, you know, this I take as a promise because it's really nice. And this came again from an experimental thing, because once I wasn't able to do this game I've shown you, and was just because there were too many clips in my chain, and I didn't know when this happened, but the magnetic field was just half intensity. In fact, when I came up to the control room and I asked the shifter what is going on with the magnetic field, he looked at me and said, how do you know that something is not okay? And I said, you know, just the clip, because it's not behaving as usual. And this person told me, yes, we are running half intensity because this morning there was an issue. So you see, it's possible. If Zoltan allows me, I would like really to
not my allowance,
calibrate.
But we can arrange something. But I just would like to make one comment to the audience, that you see how enthusiastic Sonia is, and you see how infantile she is, and this is the perfect example of a perfect physicist, you know. So this is something that we wish for you for your lifetime, that please keep this infantile, sorry for the word, but please keep this infantile enthusiasm for everything, even for the small things that you see, and that's very good. Yeah, and I really appreciate to see this.
Zoltan, you are right, because when I say, for example, to students even younger than today, I say that physics is simple, they are looking at me with their big eyes and they say, no, it's complicated. And I say, no, be right, it's complex. That means that you have to unfold problems. But this is the tricky part, and this is the part that really you enjoy, because it's intellectually challenging to unfold something to find a solution. Of course, can be tough. But when you succeed, you say, oh, I have done my day. Now, the last thing, and then I will leave the floor again. Another mess that I did is here. Once I was looking for my marvelous chain that you see now is completely magnetized, as you see, and I couldn't find. And I have always my backup here. But I thought to have found the chain, and so I was just taking one of these clips. And what happened was that the clips were not a chain, and that they went on the floor just in that way. And I said, instead of saying, what a mess I've done, I said, what I can do with this. You see them. Now look, okay, I stopped them. This is not because it's a windy zone here. Look, I can do some wind, doesn't work. But let me take a nice clip that you see here, okay? And I start to move them. Look, oh, sorry, I have even too much. You see? I can do here. I can do here. And again, I have another sensor because then, of course, I can collect these clips easily in that way. But if now I move these clips in this part, you see, they fell down. Why? Because here the magnetic field is less intense than on the other side. So it means that I can still make a qualitative analysis of the magnetic field in this zone. And this is, as you have seen, is not just because I'm here on the metallic part, because also on the floor, it happens again. Last but not the least, because I forgot, I have this, sorry. Okay, this is my, but I have this, I don't know if can you see this? Yeah. Oh, maybe we can, yeah, okay. Yes, okay, I can. Can you see this? What is it? It's a compass. You see, now, okay, you see the magnetic field lines. You see? And what is nice, I'm sorry that I have these clips. I don't know. I have to, today the clips are not perfect. I had to, it's a long time where I was not using perfectly. Now, okay, yes, it's better. I can flip this because there is not a north or south pole, but I can flip this. It doesn't, maybe it's better on the screen because it's, okay, you will see the time on my mobile phone. It doesn't matter. You see, here it's much better. And I can try to put 90 degrees, but you see, it's moving. I can put 180 degrees, you see? But I cannot put, you see, it moves alone. Okay, maybe in this way, even better. You see, it flips.
That's really a vector field.
Yeah, so you see, and again, just with a clip, this is make me crazy, frankly, that we are, of course, this is, of course, I'm not measuring, but I see nature acting under my eyes with a simple object that usually is not meant to be used for the magnetic field, but is it, you see? And you see that this is not recorded because you see the time on my mobile phone. Yeah, so, okay, I think that I leave the floor to Izaak and the crew on surface, unless you have anything else to ask me to show. I come up and then, okay, let me know.
Okay, so while
clips at the CMS gift shop.
So while Sonia is cleaning up her mess, do people have any questions they want to ask? If about the paper clips or about the CMS detector or anything else, the Large Hadron Collider?
You're not very good in the metallurgy of the paper clip.
Izaak.
No.
Izaak.
Yes, Sonia.
Sorry, this is a new entry. I forgot, but I have to show this. This is a new entry. It's the first time. So first time on the screen, just for you, CMS the duck.
That's new, yeah.
This is the first time I'm doing outside. I did inside the cavern and it was flying. Of course, here I cannot fly. It's waiting for the next flight as we will enter again on the cavern. I never did this. So.
Sorry.
What date is that?
You see, there is the chain here, but then the duck is just ticking. Moral of the duck, it seems just a bat. But however, okay. I should find the Batman figure. Okay, duck. Yes. Yeah. Yes, exactly. The bat duck I have to do. I will color in black, we do the bat duck. Yes. Okay. So I leave you the floor. This time for real.
Okay. So yeah. So if you ever want to play with the paper clips or the duck yourself, you're always welcome to come to Geneva, and we have regular visits downstairs. So if you bring your own paper clips or we can provide them, you're always welcome. Even if we're taking data and you cannot enter the cavern, you will still be able to play with the magnetic field. But this magnetic field is really like a central part of CMS. So the CMS stands for compact muon solenoid. So the solenoid part is in the name of CMS. And like I said before, without it, we couldn't be able to really tell apart positive or negative particles or precisely measure their energy. And so we really need a strong magnetic field to measure as precisely as possible the momentum by measuring the curvature of charged particles. And this is why we need this really large and strong magnetic field. And it's impressive that always to me that even if you're more than 10 meters away outside the solenoid, you still have this really strong magnetic field and you can play with it. This is also, so I mentioned before, there's another detector, which is Atlas, which has a different design. So Atlas is actually about like 5 or 6 times larger in volume. So it's not compact like CMS is, and it has really different types of magnetic fields. So it has these toroid magnets that you see here that look like ladders. And because their magnetic field is not as strong, the detector is much larger. Whereas we can really have this compact but strong magnetic field, and so we can make our detector much smaller. But what's interesting is also that even though we're smaller, we're about 2 times heavier. So it's about 14 tons or something, while Atlas is only 7 metric tons. So if there's any questions, just interrupt me. You can see in the elevator, by the way, you can see it going up. It goes quite fast. So it's now about minus 15. It's hard to read, but
they are almost there.
They're almost there already. So yeah. Okay. So I just also wanted to show you just how one of these collisions look like. So I mentioned before the different layers of CMS that do different things, and this is what we call an event display. So an event is a collision between 2 protons. And this is one of these pictures that the CMS takes as a camera. And if I zoom in, you can see all the particles emanating from the collision point. So these yellow things here are the tracks of charged particles, and you can see that they're curved in this magnetic field. And these are quite high energetic particles. And then these green and blue bars, these are energy deposits from either photons, electrons, or hadrons. So the ones in green are from the electromagnetic calorimeter, and then the ones in blue are from the hadronic one. The blue is just to show you kind of where the tracker is. And then these red lines here, they go outside, and you see here some of these muon chambers or muon detectors outside that also measure a muon passing through. So this is something that we can look at for a single proton collision, but typically if you want to do really data analysis or really want to search for something like the Higgs boson, you have to look at thousands or even millions or tens of millions of these events. And instead, we typically use histograms, but still, once in a while, we make these really beautiful plots. Here's just an example of a different event display looked from a different angle. And it's also showing in red and gray here the outside of the detector where you have the muon chambers. So this red is actually steel, which is meant to make the it's called the steel yoke, which is meant to improve the magnetic field outside the magnet, because it's not as strong outside as it is inside the solenoid. So let's
interject.
Yes.
So the class is very nearly over here. So I just wanted to say thanks a lot. I mean, I think this has been super interesting. There's still some students here. Could we give our hosts a round of applause? The students are going to start slinking out of the room, so I wanted to do that before that happened. And I don't know if you have anything you wanted to say at the end before they have to go, or
no. Sonia is here, so Sonia, we have to run up, but maybe we can just quickly flash the control room where we have some shifters working.
Yes, I go around. You can comment.
So behind me, you can see a lot of monitors and some people working. So we've been disturbing them for the last
they got
hour.
frozen, right?
So
yeah.
Okay. Now we can see. So this is the so-called technical shifter position. And so Sonia here is pointing to some cameras of the underground. So this is for safety, to see what is happening downstairs, if there's people. And also downstairs, you can see some parts of the detector. So you can see there's a lot of green, which means it's good. So this one's for radiation. The one on the left is just to see if everything is powered up, all the electronics are working. So this is kind of like the Homer Simpson station, where we have to make sure nothing is flashing and everyone is safe when they go downstairs. If something happens, then we have to call experts for specific subsystems. So Sonia, is there anything you want to show before we end? Is there anything you would like to show in the control room before we end? Yes.
You are not
so there's
having the microphone on.
Sorry. Okay, you can proceed. Just comment right, please.
Yeah, that's also true.
Just the last comment before we wrap up.
I lost my microphone. I wanted just to show people working, not specifically. Okay, of course, as you can imagine, we have a different pose, and with many. Okay, you see, very nice people just saying hello to everybody. So they are always smiling. I think this is the most important thing, that even when you are a shifter, you smile, even after 8 hours of shift. And then here we have the trigger, and we go back, and now we see our Zoltan and Izaak and me, and maybe I can show Noemi. Okay, yes, that she was the key person here for the visit underground. Okay, so there are any other questions? I'm alive. Okay, so I survived underground with the clips.
You magnetized, but not radioactive, I hope.
I say something that when I enter the cavern and there is a magnetic field, I magnetize my earrings. It's really crazy, and also my shoes. Yeah.
The steel tip. Yeah.
Yeah, because here there is a metallic part, and when you walk inside the cavern, it's really curious. It seems that you are floating in the air. And just to say, because I heard that you were mentioning Atlas and CMS. Yes, it's very light, Atlas. It's bigger, but very light. And we are used to say that Atlas is a souffle and the CMS is a brownie.
Well, what we used to say that if the Atlas is so big with respect to its weight, that it's so less dense, that if you would put cling foil around, it would float on the water. We already proposed it, but Atlas guys didn't like it.
I heard some worst things that Atlas floats on the water and the CMS sinks.
Yes.
And depends on which collaboration you are belonging to, you can have the bad or the good interpretation.
Connotation. Yeah, exactly.
Yes. Yeah.
I think they're both great. I used to work on Atlas, so.
Careful.
No, I'm not mentioning what they say about the interpretations.
Sure.
Otherwise,
course
can be.
not.
I need to be diplomatic.
No, but we are very good colleagues of each other. That's the truth.
Scientific collaboration.
Exactly.
Very good. Okay. So thank you once again. So I think the students need to go to their next class here. So we'll let you go. But thanks very much. And I think this was definitely memorable. There's some smiling faces here. So thank you for the time. Have a good day.
Thank you so much for joining us today.
To see you.
Ciao, ciao.
Bye.
Bye.